Hi, so in today's video I thought I'd talk about the difference between the cases where you do and do not use quotes when scripting in Bash. So yesterday I made a tutorial about the difference between the single quotes and the double quotes, and today I thought it'd be nice to cover the cases where you don't use any quotes at all and compare it with cases when you do. So that's what we're gonna do today. Um, so I'm gonna start off with by referring to this Stack Exchange post, which kind of summarizes the difference between when you don't have any quotes in between and when you do have double quotes in this one sentence very nicely. So they say that without quotes, the string is subject to word splitting and globbing. And basically, let's go ahead and take a look at those two things and understand what they exactly are. So let's start with the word splitting. Now, so word splitting is essentially something that Bash does when it can split contents of a variable at certain points where a certain character occurs. So for example, let's create a variable called a, and I'll put just like a space b space c in that variable. So now if I'll use printf for this so that I can print every argument on a separate line. So if I just pass $a quoted, it will just print the entire contents of the variable. But if I remove the quotes and run this command, then you see that every single letter became its own argument, and so we got 3 letters separated by new lines. So like, just to make it super clear, I think it would be nice to just create a little test script. And so user ben env bash, and let's create just the following content. So I'll just use echo here because this doesn't matter in this case. So first I'll just basically I'll print out the contents of the first, second, and the third positional arguments, so that it's really clear what happens here. Because like every command would that you run in Bash will kind of act in the same way as a script does. So like when you pass arguments to a command or to a script, they become these positional arguments, and basically using the quotes and not using the quotes in this case will affect what becomes an argument. So I'll make that script executable, and I'll run it, and I'll pass our a variable to that script first quoted. So when I pass it quoted, the first argument becomes ABC, like the entire string, and the second and the third has nothing because we didn't pass any second and third arguments. So if I pass something like I don't know, like X and Y here, then they will become the second and the third arguments. But like if I remove the quotes due to word splitting, A, B, and C now become the first, the second, and the third but you get what I mean, positional arguments. So this kind of demonstrates the same thing, just like in a different way, by using this test script. But with printf, the same thing is happening. So this is kind of the word splitting in a nutshell. Like one thing that is also important to know about it is that splitting occurs like at certain characters. So we saw here that the space was the character was where splitting occurred, but actually there's a variable in bash. I'll show the contents of that variable with declare, because it's going to be hard to see if I just echo it out. The variable is called IFS, and that stands for internal field separator. And basically that variable contains a series of characters, and by default it's a space, a tab, and a new line. So basically either a space or a tab or a new line by default will act as this field separator, and when you don't quote a variable, it will get split if there's one of these characters, if one of those characters occurs in that string stored in that variable. But I mean, you could of course set the internal field separator to something else, but we're not going to talk about that a lot in this video. But basically, you can change it to like anything else, and it basically works on per character basis. So you can add like a comma here or something, and then the comma would become a character that also acts as a field separator, and it would work just the same. So I think this should kind of make it pretty clear what word splitting is. Now, basically, personally, well, like in practical terms, I really don't ever use word splitting in this way in my scripts. I would kind of do other things if I need to store a series of values, then there are arrays in bash for that particular purpose. So it's not a really it's not something that I use like I can't like even think of cases where I like would ever use word splitting in this way, but this is how it works, so it can be used, and it's important to know about. So so yeah, this is word splitting. Basically, there was the second thing, globbing, and let's talk about that now. So so what is globbing? I just ran a list because I wanted to check if I have any files here in this folder, and I do. But well, let me actually remove those dash test files. I'm actually using a glob pattern here to remove them. Like a star is like one of the characters that you can use, special characters that you can use in a glob pattern, which kind of replaces any number of any character. So I'm gonna create some new files just so that it kind of looks a bit more familiar, perhaps. I just wanted basically to have like maybe let's just go like 1 to 5.txt, and that will create 1.txt, 2.txt, etc. until 5.txt. So we have like 5 text documents here. Now, what is globbing, and what does it do? Basically, globbing is a way to match files on your system, but so that you don't have to select every single one of them. You can use these kind of shorthand ways of writing things, and like one of them is like this is the star, for example. So like if I use our printf command again, which just prints every single argument on a separate line, now I could pass like star.txt here, and then that would turn into 1.txt, 2.txt, 3.txt, etc. So it would be the same as doing this. What the script or the command receives is not star.txt, it sees only this. So I mean, let me actually use that test script to kind of let's create the fourth and the fifth, since we have five files. So let's like just enable syntax highlighting because it looks nicer. But so where's our test script? So for example, if I pass start.txt to my test script, what the script receives, you can see that it received 1, 2, 3, 4, and 5.txt, and this is what it prints like. So it never sees the start.txt at all. That's just a way for us, a shorthand that we can use to pass multiple files as arguments by using like fewer keystrokes, essentially. So there are other globbing characters, but this is not a tutorial about globbing, so I'm not gonna like really explain too much about this. There are other globbing patterns that you can use that can be very helpful when passing files as arguments. There's a question mark that only stands for one character. The star can stand for like any number of characters. Then there's also extended globbing, which you need to enable to use, but you can enable with by running shopt-s, so like shell option set ext glob. That will enable it. You can test if it's already enabled by running shopt-ext glob, and then it will tell you if it's enabled. For me, it's already enabled because I added it to my bash rc. So you can just add shopt-s ext glob to your bash rc, and you'll get more globbing patterns. Let me just open a bash manual ext glob. So here is the list of all of the possible things that you can do with the extended globbing, and it's pretty nice. You can have like a list of for example, I could only pass like 1 or 2 or 3.txt, and then that's what it would match, but not the 4 and the 5, for example. Or I could do like not 1 or 2 or 3, and that would match only 4 and 5. So extended globbing is very handy. I always have it enabled. So, but let's not spend too much time talking about globbing, because we're talking about the topic of this tutorial is about quoting and lack thereof, and what happens when you use either of those two options. Okay, so globbing. Now, what happens when, like, essentially, the way it ties into quoting is you can basically store a glob pattern in a variable. So let me just kind of create set our a variable. Let me clear the screen. So I'll set our a variable to star.txt, and that's going to be just a string that I store in there. So if I printf that variable and I quote it, then it'll just print the string star.txt. But if I remove the quotes, then that will act as the glob pattern, and then we'll get all of our arguments. So the glob pattern will expand, and it will match in the same way as it does when we just type it in directly like this. So this actually is pretty neat, and like I do use this in my script. So sometimes if I need to match files and I need to store a glob pattern in a variable, you can do like interesting things with that. So this is pretty handy, and I do use this. So essentially, we have talked about the difference between the double quoting and this, and no, in the cases when you don't use any quotes, and like what the difference is. This is kind of the most important stuff. Now, there's also certain cases in Bash where you don't need quotes at all, because in those cases, like there is basically no difference between whether you use them or don't use them. Like Bash in those cases always basically acts as though there were quotes, but you can just omit them in those cases. So these things are also good to know about, so that you don't kind of overuse quotes in cases where they're just like not really necessary. So I found this other answer on Stack Exchange where someone put together a really good reference for the cases where you can omit the double quotes. And basically, let's kind of go through those, and I think it's pretty useful to know about these things. So now the first case that they mention is when you assign something to, like when you assign the value of one variable to another variable. When it's just like this, var equals $, another variable. Like, so if I had like b equals I don't know, a, b, c, d, e, f, for example, so I could say like a equals $b, and that would still work just fine without me needing to quote it. But this is actually a case where I do quote it anyways, because it just like, to my eye, this looks more clear, and it just kind of looks weird when I have a script and I have something like, like a equals $b, just like this without quotes. Like for some reason I want to have quotes there. It just looks more clear to me that way. But then there's also another case, which is like, it's kind of the same. We're still on the same point, but basically you can also assign a command substitution to a variable, which is basically, it's this thing. It's output of some command. So let's just like run ls and assign its output to a variable. So ls outputs this, except for the color. When it outputs to the variable, it disables color automatically. But basically, so now since I ran this a equals $, and then in parentheses ls, now if I echo out the a, it contains like the output of ls. Like in this case, you don't need quotes, and I don't use them either. If I have like a command substitution, I just do this, and I don't use quotes in that case. Like if you have a command substitution, like command substitution essentially like acts a lot like a variable. So like if you want to pass command substitution to some other command, like maybe like whatever, like I could pass it to my test script, and then if I want the entire thing to be an argument, then I need to quote it, because like C, like it output the entire thing to the first argument. If I don't quote it, it will word split just like a variable would, and I don't know, like we would get 1, 2, 3, 4, 5, and then there was a 6 as well, but I just don't have it listed here. So if I add it, then it would also be there. So this word splitting works the same for variables and command substitutions. So basically, you don't need to quote the variable or the command, a variable or command substitution if you assign it to another variable like this, but I personally prefer to still quote if it's a variable. Now in a case statement, I never quote a variable in a case statement, just like quotes are not needed there at all. You could quote it, but it's just like this is an absolutely clear case where quotes are not required. Within double brackets, now this is something that is also worth spending a little bit of time on. So basically, if you have something like this, in this case, like maybe, let's say I have a equal 1.txt, and then I want to test if there's the file there. I can just do this, and I guess I need to put something like echo test. So basically, if this condition is true, then it will print echo test, and if it's not, then it will do nothing. So it prints, it works basically. Maybe I could do, like, just to make it super clear, I could create another file. I'll call it like A, B, and C with spaces .txt, just to show that like nothing breaks, and I can then assign abc.txt to the variable, and do this, and it still works just fine. So like you don't need a quote in that case. Also, if you just are testing if the variable is set or not, you can just simply do this, and that also works perfectly fine. So no quotes are needed in this case, but they are needed, or there is like a difference between using the quotes and not using the quotes when it's on the right sign of like of an equal sign like this. So let's create an example to demonstrate this. I'll create a variable called a, and I'll put I'll set it to just abc, and I'll create another variable called b, and I'll set it to start c, just like this. And now let's compare these two variables with a conditional. So let's say see if $a, I usually use a single equal sign. They use like a double equal sign here, but they are in bash, they have no difference. There's no difference in meaning. It's just like it's there to like an alias basically. In other programming languages there is a difference, but not in bash. I usually use the single equal sign, so I'm gonna stick to that here. So yeah, let's compare A and B, and then if it's success, let's say success. So note that I did not quote the B, and like if I do this, then like ABC equals star C. So this star C was treated as a glob pattern, and it, since A and B basically match to the star and the C match to the C, so they are equal. But if I quoted the B, then it would be treated as literally star C, and then ABC does not equal star C, and we don't get this success output. So this is a difference that is really important to know about, and it's also useful because sometimes you might want to use globbing. In this case, like usually, like I said before, that globbing is used for file names and stuff, to match file names. But in this case, you can see that you can also check, make comparisons between strings basically by using globbing as well. So this can be very useful too, if you need to check if some value stored in a variable matches this particular pattern, and you can do stuff with that. So this is an important difference. But as you can see, like on the left hand side, I didn't use quotes, and they are never necessary there, even if like the variable contains spaces or whatever. It doesn't. They're not necessary there. I never use them in that context either. So then there's also yeah, this case does not apply to bash, but to other shells, so let's skip that. Inside an arithmetic expression, yeah, like so if you have like a equals 1 and then you can do arithmetic and bash by using this construct. Again, acts the same as command substitution, variables and stuff. So you can have like a variable here and maybe like 1 plus 2 and then you get output 3. So I don't know if like it's gonna work if I double quote, like use double quotes on it. Let's see. It still works, but it's not necessary there. And in fact, not only are the double quotes not necessary here, like the dollar sign isn't necessary either, because inside this arithmetic construct, the letters are automatically interpreted as variable names. So this will work as well. And then there's also one other case listed here in an associative array subscript. So like in bash you can have associative arrays, which basically yeah, like it's like an array, but you can have not just the like numbers. So for example, like in a normal array you can have like, if I create an array like ABC, then if I go like A0, that will be equal to A, A1 will be equal to B, and A2 will be equal to C. Like if I created an associative array, let's do that. Let me unset my B variable that I created before, B. So to create an associative array, you need to use the declare command with a capital A option, and then set it to B, and then you can have like essentially you can use anything as a key. And basically, what do they say here? So you don't need to like use the double quotes. Yeah, like if you, so for example, I could yeah, like I can use like have any key. So like let's say like ABC equals I don't know, like QWE, and then I can do like B ABC that is equal to QWE. So these are also very useful things to have in scripts. Yeah, but you can so you can of course store the key in some variable, and then when you're assigning it to the array, you might want to retrieve that key from a variable. So let's create like another variable called C, and let's call it, I don't know, IOP or something, and let's set like B. Yeah, like IOP doesn't really make sense. Let's use spaces there so that like it's clear that quoting won't like, or lack thereof will not affect the final result. So let's say like B I space O space P space, and we have that stored in the C variable. So we'll use $C in square brackets, and let's set it equal to like something 789. So And now if I press enter, everything like works, and I can retrieve that. So like it was I space O space P space, and the value is still retrieved, so the array works. So so yeah, this is basically all of the cases where you could use quotes, but you don't have to. So yeah, I'll leave links to these articles and question answers in the description below, so that you can take a look yourself. I often refer to these answers if I forget something, so they're good to know about, especially like this one, this list. If you you might forget like when you can omit quotes or when you can't, you can just kind of open this and quickly figure it out. So yeah, basically this is it. Like, to summarize, essentially when you mostly want to use double quotes almost always, unless it's one of these like exceptions where when they're not required, just because of how bash works. But like in all the other cases, it's generally a good idea to quote because it just kind of looks clearer. And again, like yesterday we talked about in the previous video where I talked about the difference between the single quotes and the double quotes, I mentioned something about like semantic significance of like the difference between the single quotes and the double quotes. So like single quotes just clearly indicate to someone who reads the script, looks at it, and just tries to understand how this works. So to a programmer, it's immediately obvious that like if it's single quotes, then that's a literal string. If it's double quotes, then it's a string that is intended to be a single argument. Like let's say something, again, like we have some value stored in a variable. This was, I think, our first example today. And so if it is quoted, then it's immediately clear that like, okay, that's something that is stored in a variable and it's quoted, so that's an argument that goes to some command or a script or something. And that is the intended meaning. So there's like a meaning already embedded in that. So, and when quotes are omitted, it is also it also conveys a certain meaning. If you kind of understand how everything works, it can convey the meaning of like, this is a string that is intended to word split. And instead of kind of thinking like, well, is this something that will never word split and that's why they omitted the quotes, or is it just something that could word split and the intention is that it will word split and that's why there are no quotes? Like it just like becomes really more difficult to read scripts when quotes aren't used in this way. And I think like the meaning of that particular bit of the script is what is important to consider when making a decision whether to quote or not. So lack of quotes is also significant in the sense that it's either a string that is intended to be word split, or it is a string that is intended to be a glob, contain a glob pattern. So that there's like one of those things. And if you see that it's not quoted, then it's just like your mind can immediately goes to those possibilities. When you write your scripts taking into account these factors, and then it just becomes much easier to read them and to manage your code when those things form the basis of the style that you write in. So yeah, these are my thoughts on when to quote and when not to quote. So yeah, this is basically it for this video. I hope this video was useful to you and that it helped you clarify the difference between omitting the quotes and using them, and what happens when you omit the quotes, which is again like word splitting and globbing. So once you understand these concepts and what happens in each case, it becomes much easier to write scripts and make sure that they actually work the way you intend them to, and it makes it much easier to make decisions when to use quotes and when not to use them, even in cases where it's strictly not necessary, but you might make some stylistic choice to make your code more readable and just clearer to to someone when they look at it. So yeah, thanks for watching, and I hope you liked this video, and I'll see you in the next one.